Hi, welcome to Unix Academy. This is Jyoti. In this video, we will talk about implementing persistent storage using persistent volumes and persistent volume claims. And we will demonstrate how to set up a PV and PVC to consume storage resources in a pod. Managing storage is a distinct problem from managing compute instances. The persistent volume subsystem provides an API for users and administrators that abstracts details of how storage is provided from how to consumed. To do this, we introduce two new API resources, persistent volume and persistent claim. A persistent volume is a short form of PV, is a piece of storage in the cluster that has been provisioned by an administrator or dynamically provisioned using storage class. It is a resource in the cluster just like a node is a cluster resource. PVs are volume plugins like volumes but have a life cycle independent of any individual pod that uses the PV. This API object captures the details of the implementation of the storage, be that NFS, ISCSI or a cloud provider specific storage system. A persistent volume claim is a request for storage by a user. It is similar to a pod. Pods consume node resources and PVs consume PV resources. Pods can request specific levels of resources like CPU and memory. Clients can request specific size and access modes. They can be mounted read write once and read only many or read write many. PVs are resources in the cluster. PVCs are requests for those resources and also act as claim checks to the resource. The interaction between PVs and PVs are provisioning. There are two ways PVs may be provisioned, statically or dynamically. Static. A cluster administrator creates a number of PVs. They carry the details of the real storage which is available for use by cluster users. They exist in the Kubernetes API and are available for consumption. Dynamic. When none of the static PVs the administrator created match a user's persistent volume claims, the cluster may try to dynamically provision a volume specifically for the PVC. This provisioning is based on storage class. The PVC must request a storage class and the administrator must have created and configured that class for dynamic provisioning to occur. Clients that request the class effective disable dynamic provisioning for themselves. Without further delay, move to implementing persistent storage using persistent volumes and persistent volume claims. I will give the descriptor to create the persistent volume. I am using my-pv.yaml name for this file, and I will give the descriptor here. API version v1 will be acceptable for object persistent volume. Kind is persistent volume. This is a Kubernetes resource. And metadata section, I am giving the my-pv for this persistent volume name. Spec section, I will provide the storage class name, local-storage and capacity storage 1 gigabytes, and access modes are read write once, and host path. I am providing /mnt data here. This is the persistent volume descriptor. We should remember the storage class name, local hyphen storage is name. Then we will provide this name, this storage class name, key name we will provide in persistent volume claims descriptor. Then I'm going to save this file. Then I will create the persistent volume hyphen f. I will give this name. I will create the persistent volume. My PV was created. Then I am going to create persistent volume claim. Now I will give the persistent volume descriptor on my pvc.ml file. Descriptor was API version v1. Then kind is the object to the Kubernetes. So we will give the kind as persistent volume claim. Then metadata section will give the name for this object. Then spec section I will provide the storage class name which is used in storage persistent volume name I will use here. Then only persistent volume and persistent volume claim will be interactive. Then we will give the access modes, read write once, resources and requests keys. Resources key we should provide here. How much resource we want, those requests key we will use. And storage 512 megabytes needs this persistent volume. How much you need in that persistent volume storage size, need to provide the you need to select the storage key, then we need to provide the size and save this file. Then I will create persistent volume claim. kubectl create a hyphen f my pvc.yml descriptor file name will provide persistent volume claim also created. We can check with this PV and PVs list. We can list it kubectl get PV. I will provide for this PV list. Will list the only one persistent volume is there and 1 gigabyte size. Read write once, the access mode and reclaim retain status bound. Claim default my PVC storage plus local storage. Then I will list the kubectl get PVC. It will list the PVCs on this Kubernetes. You can see name was PV my PVC and status was bound. Then my volume my PV 1 GB capacity, access mode, read write once and local storage is storage PV storage. Here you can see the PV storage, local storage and PVC storage also local storage. This is the class storage class name. And last step is create a pod to consume storage class using a PVC. I am giving the descriptor on my hyphen PVC hyphen pod.yml. Descriptor was API version v1 kind pod. Metadata section I will provide the my hyphen PVC hyphen pod for this resource. Then spec section I will use containers key. Then name busybox image, busybox image. Then commands I provided. Then mount volumes I will provided first. Then my storage name I am using here. Persistent volume claim name we should use my PVC here. This is the important point. This claim name should be the perfect name which is using on persistent volume claim. Then volume mounts will give the slash mount storage. Then I am giving my storage. I will save this file and we will see what is the difference of the how to interact PV to PVC and PVC to pod. Now I will create first pod kubectl. Kubectl create open here are also created. Here I am going to show you 3 parts which is created in this video. Then first my -pv script are looking in this first. I am using here duplicate sections only, not a different nodes. These 3 nodes are same IP address. You can observe these IP addresses. This is my persistent volume descriptor. Here I am using the storage name local storage. Then capacity I provided, storage key I used for capacity 1 gigabyte I provided for this storage class, means persistent volume. Then access mode I gave read write once. Then host path where this data should be host path. We should provide this path. You can provide any path here. I provided /mnt and data path. Then you are looking on this second terminal. This contains the persistent volume claim descriptor. Here also I am using a storage class as a local storage. It will both will be interact with this storage class name and access modes. Here I provided read write once, same I provided on my persistent volume claim descriptor. Then resources, we gave the resources on capacity on the persistent volume. Here on the persistent volume claim, how much request you should provide using by storage key. 512 MB is enough to the resources for this persistent volume claim. Then how to interact with these with the persistent volume claim with pod. I provided the third terminal pod descriptor. Here you are looking. Here I am giving the kind pod and container information. Then volumes, I used my storage this name, and persistent volume claim, this claim name should be the persistent volume claim object name we should provide on the pod descriptor, pod spec descriptor. Then this volume name we should provide the volume mounts. First we will give the information of volumes. This claim name should be the persistent volume claim object name, and this volume name we should provide on volume mounts key. Under the volume mounts key we will use different path here /mnt storage. This is a different. This is also different. Name was my storage. This should both should be the same. Names, volumes and volume mounts I explained in my previous video, which is in MTDIR. Also we provided volumes and volume mounts with the same names, and config maps and secrets videos also is contains the volumes and volume mounts. You can observe these videos how I provided volumes and volume mounts. Then I'll give the kubectl get pods list command. My PVC pod was created one by one, ready and status running from the edge also it is showing. Now I will use the kubectl describe, then pods, pod name I will provide my hyphen PVC hyphen pod here. It will describe this. My storage is a volume. My storage is the volume name on pod descriptor. Then persistent volume claim is a type of volume. In our previous video we saw as MTDIR, here type was changed to persistent volume claim, and claim name my PVC. This is a persistent volume claim object name, and read only false. He did not provide any read accesses to this pod. So it is only read once colon false is showing. You can provide this also on your pod descriptor. Before conclude this video, I am going to explain one more time about this volumes, persistent volume and persistent volume claim, because of volumes are important to Kubernetes cluster. Here you are looking the persistent volume object descriptor and persistent volume claim descriptor both. And PVC. PVC is a abstraction layer between pod and PV. And PVCs automatically bind with PV. You can use this kubectl get PVC command. It will show the bound storage status is a bound. It will automatically bound with PV. Here you can see the PV volume name, and this is the PVC volume. And on persistent volume descriptor, capacity is some storage amount for PV, and access mode is when the volume mounts read write once it will determine, and host path is nodes will use this file system path. There is a host path and this file system path. And on persistent volume claim resources request, we will provide storage of 512 MB. This means how much storage claim needs for this storage claim. Here should be bigger amount, and here we can give same equal amount of this or less amount of storage we can provide here. And one remember point is storage class in both persistent volume and persistent volume claim should be the same. Then only persistent volume claim will bond with persistent volume. That is about the volumes on Kubernetes cluster. Subscribe my channel for further notifications. Thank you.